My goal with this video is to show you where the predictive model we calculate using computer software comes from. This predictive model is called a least squares model, and these models are widely used in companies. You've certainly seen them if you've taken a basic math or statistics course. Quickly watch this video, even if you understand least squares. If you have limited experience though with least squares, take a moment to see the extra resources we've posted for you. We certainly want to give you as much help as we can.
Now in the videos in the prior module we were looking at popcorn, and I'm going to use that example again in this class. In the popcorn experiment, our objective was to maximize the amount of popcorn created. Our outcome variable was the number of popped kernels. Here is the cube plot and the corresponding predictive model that we created. The predictive model has 4 parameters: 67, 10, 4, and -1. 67 was the baseline amount, the average of all 4 experimental outcomes. We also refer to that as the intercept, and you'll see why in a minute. 10 is the effect of factor A, the cooking time. This is what we call the main effect for factor A. 4 is the effect of factor B, the kind of popcorn we used. And lastly, the -1 is the two-factor interaction term. Do you recall how we calculated those numbers by hand? Go back to the videos in the previous module if you are not sure. The most general form of the least squares model for this system is y equals b0 plus ba times xa plus bb times xb plus bab times xa times xb. The xa is the coded value for factor A, and it represents the amount of cooking time. If xa is -1, that represents 160 seconds of time, and xa equal to +1 represents 200 seconds of cooking time. The -1 and +1 are called coded units, and the 160 seconds and 200 seconds are called real-world units. Note that we cannot use real-world units in this equation, only the coded units. Similarly for xb, it is coded so that -1 represents white corn and +1 represents yellow corn. Similar to the xa case, -1 and +1 are the coded units, while white corn and yellow corn are the real-world units. Recall that with categorical variables, we assign the -1 and +1 arbitrarily. The sign of the coded unit will not change the model's interpretation. Now take a look at what happens if I write that equation down for each of the 4 experimental points in the system. We can substitute in values for the coded units into this prediction equation. For the first experiment, for example, we would have y1 equals b0 plus ba times xa minus plus bb times xb minus plus bab times xa minus times xb minus. That's because xa is at the minus level and xb is at the minus level for the first experiment. We can repeat this process for the other 3 points in the cube, as shown here on the screen. Now let's go substitute in -1 or +1 for the factors a and b, and we will get 4 equations. Notice that the 4 equations have 4 unknown parameters: b0, ba, bb, and bab. If you have some mathematical background, you'll recall that 4 equations with 4 unknowns represents a set of equations that we can solve. These equations are linear, and so they're very efficiently solved using matrix methods. Let me show you how. In matrix form, the equations are written as shown here on the screen. 3 things quickly become apparent. Firstly, we notice a column of 1s in the first column. That corresponds to this parameter b0, the intercept. Next, we notice that the second and third columns, in other words the columns that correspond to the parameters for a and b, are simply the columns from the standard order table. And finally, the last column corresponds to the two-factor interaction for ab. You'll notice that this is simply the column for a multiplied by the column for b. This comes from minus times minus is plus times minus is minus times plus is minus, and finally, plus times plus is plus. This entire set of equations can be written as vector y equals matrix x times vector b. Now for those of you with some background in linear algebra or least squares will recognize that the solution to the set of equations is b equals x transpose x inverse multiplied by x transpose y. If you don't have that experience, don't worry. The computer software will solve these equations very efficiently for us. That's what computers are good for. All we require is the x matrix and the y vector. And we have these. The x matrix is assembled from the standard order table, and the y vector is simply the 4 experimental outcomes. The software will calculate these 4 parameters, in other words, the 4 entries in the vector b. Those correspond to b0, the intercept, ba, bb, and bab for the two-factor interaction.
So now we are ready to use the computer software. Please watch the next video to see how those 4 parameters are calculated.